Here we're going to talk about section 2.5 in our book, Composition and Inverse Functions. So we're looking at a couple of functions first given as equations. F of x is equal to 2x plus 5 and g of x is 5 minus x squared. So I'm going to try to give you some of the different notations we might see. So f of g of 3 means we're first going to plug 3 into g. And so that means that g of 3 is going to be 5 minus 3 squared, which is 5 minus 9, which is negative 4. So that goes into our function f, and we're going to evaluate negative 4. And so that will be 2 times negative 4 plus 5. So it looks like negative 8 plus 5, which is negative 3. So f of g of 3 is negative 3. Now in general, you can't, if you change the order, you get a different answer. So if we look at g of f of 3, then first we're going to plug 3 into f, and that's going to be 2 times 3 plus 5. So that's going to get us to 11. So that means we're going to take g of 11. So that means we have to go 5 minus 11 squared. How well do you know your squares? So that's 5 minus 121, which is going to be a negative 116. So g of f of 3 is negative 16. Now we can also see this written with different notation. So this f composed with g of 2, that means the same thing as f of g of. And so we're going to first here again find g of 2. So that's going to be 5 minus 2 squared, which is going to be 1. And that will in turn go into 1, which is going to be then 7. And similarly, we can get g composed with f of, say, negative 4. So that means we're going to have to first find f of negative 4, which is going to be 2 times negative 4 plus 5. So negative 8 plus 5 is negative 3. So this becomes g of negative 3, and that's going to become 5 minus negative 3 squared, which is 5 minus 9, and we'll get negative 4. We can even do crazy things like f of, say, 5. So we can first plug 5 into f. So that would become 2 times 5 plus 5 would be 15. And then we turn right back around and plug that into f again. This time we'll get 2 times 15 plus the 5. And so we'll get 35. We can even do it with x and create a new function. So in this case, we're going to plug into f g, which is 5 minus x squared. So we're plugging in that 5 minus x squared where we see the x in f. So that's going to become 2 times 5 minus x squared plus 5, and that's going to be 10 minus 2x squared plus 5, which is going to become 15 minus 2x squared. So we create a new function, f of g of x. And similarly, g of f of x is going to be 5 minus, and then we'll plug in f in place of that x. So remembering to square that out first before we distribute the negative, that's going to be first one squared twice the product plus the second one squared. We can distribute that negative, so that's going to make everything be negative in that parentheses, and finally combine like terms. So we'll end up with the new function, g of f of x, is going to be negative 4x squared minus 20x minus 20. And we're going to do the same kind of thing, composition, but this time I'm going to give you your functions f and g are going to be given numerically, that is as table of values. So the x values are going to go negative 1, 3, 7, and 11, and the f of x values will be 8, 2, 3, and negative 2. And I'm going to do the same thing for G. And for G, we'll say F is negative 2, 0, 2, and 4. And the G values will be 8. Hold on there, I got the wrong number. How about 15, 7, 5, and 3? So now, like we saw before, we can ask what is f of g of 0. And as before, we first have to figure out what is g of 0. And so that's going to come from our table, and we'll get 7 for that. So that becomes f of 7. And we look on the table for f and see that that is going to be 3. So f of g of 0 is 3. In a similar fashion, g of f of 11, we first figure out f of 11, and in our table, we see that that's going to be negative 2. So g of f of 11 becomes g of negative 2, and on the table for g, we see that that's 15. And on f of 7, we first find f of 7, and we did that earlier and got 3. So f of 7 becomes f of 3, which we see is 2. Okay, I'm going to go to a new panel and talk about inverse functions a little bit now. Hopefully most of this is review. So for inverse functions, if we consider the function f of x equals 3x minus 2, then I can ask you several questions. First, can we find f inverse of x? And the standard way that I believe you probably learn that is you will rewrite the function notation as y equals 3x minus 2, and then you can switch the values for x and y and solve the resulting equation for y, and that will give us the inverse, which notationally we'll write as f inverse of x, and you can either write it as x plus 2 all over 3 as one big fraction. You could also split that up and call it 1/3 x plus 2/3. So those are equally acceptable for the inverse. So let's look at the graph of this, because what we want to also understand is the relationship between a function and its inverse graphically. So I'm going to graph f in yellow. So we have negative 2 is the y-intercept, 3 is the slope, and so our graph of f of x is going to look like that yellow graph. If we then do the graph of the inverse, now I'm going to do a different strategy here. Instead of doing the 1/3 x plus 2/3, I'm going to come back and look at these ordered pairs that we had on the original function f, and just to illustrate here another strategy, we can switch the x and y's in the ordered pairs. So in this case, 1, 1 is going to remain 1, 1, and 0, negative 2 will become negative 2, 0. And if we connect those points, we'll get that straight line that you have to use your imagination on the straight line part. Let me try that again. Is going to be more about like that. So visually, what we can see is that the original function, which we had in yellow, and the inverse function, which is green, are reflections of each other in the line y equals x. So if you fold on that dotted red line, they'll land on top of each other. Now, the definition of an inverse is actually that f and g are inverses of each other. So it's a reciprocal operation. If f is an inverse of g, then g is also an inverse of f. And then we say if and only if, which can be abbreviated this way, f of g of x equals x, and g of f of x equals x. That is, they have to undo each other. So what must be true then is that f inverse of f of x must equal x, and f of f inverse of x must also equal x if these are inverses. So I'm going to ask you to verify that the f and f inverse that we just found are in fact inverses. So what that means is we have to show that these two things are true. So we're going to say f inverse of f of x is 3x minus 2. So I'm going to plug 3x minus 2 into f inverse where we see x. I'm going to choose the version that's the big fraction. So that's going to be 3x minus 2 goes in for the x, and then we have the plus 2 over 3. Now we can cancel those 2's, and this is going to become 3x over 3. And then we can cancel the 3's, and we do in fact get x. So f inverse of f of x is indeed equal to x. Similarly, we have to show that f of f inverse of x is going to equal x. So this time I'm going to pick f inverse, and I'm going to again pick this version right here, the big fraction, and plug that in place of x in the f function. So that's going to become 3 times the x plus 2 over 3 is going in place of the x, and we still have that minus 2. So we can then cancel these x's, and this simplifies to be x plus 2 minus 2, and then we can cancel those 2's, and so it is equal to x. So what we see is that these two things together verify that f and f inverse are in fact inverses of each other. So let's do something like, I'm going to go to a new panel here, and we're going to say if, I'll give you a verbal representation of a function, if y equals p of t is the population of mosquitoes in Laramie, t in millions, I'm going to say in millions, t days after June 1st, then I'm going to ask you a couple of questions. The first is, what does P of, my pen quit on me there. Okay, what does P of 5 represent? And when you, hold on a second. Okay, what does P of 5 represent? And use the correct units when you answer that. I'll let you have a moment to think on that. And the second question is going to be, what does, this is going to be a little more challenging, what does P inverse of 5 represent? And again, we're using correct units. So, P of 5, now remember in our function, the P of t is our population of mosquitoes in millions. So P of 5 will represent, and it's supposed to be actually t days after June 1st. So it will represent, P of 5 represents the number of mosquitoes in millions 5 days after June 1st. I guess that would be June 6th. Now, the inverse, this gets a little trickier because I almost have to think out loud here. So we are switching the role of y and x, or in our case, p and t. So the 5 here is not a t value, it's a p value. And what this is going to equal is a t value. So we are going to get something like that would make sense. That's accurate. So this P inverse of 5 represents the t value, the number of days after June 1st, when, and the 5 is our population, when the mosquito population reaches 5 million. These are head scratchers. You have to think about this a little bit. Okay. Let's revisit our cricket, our thermometer cricket, where we know that the temperature is equal to 1/4 the rate at which that cricket chirps, plus 40, where T is in degrees Fahrenheit, and R is the number of chirps per minute. So can we figure out, can you interpret? So can you interpret what does T of 80 equal to 60 mean? And then I'm going to ask you also to interpret what does T inverse of 65 equal to 80 represent? And we're going to use units when we talk about this. So in our temperature function given here, we are inputting the chirps per minute. So that's telling us that when the crickets are chirping at 80 chirps per minute, the temperature is 60 degrees Fahrenheit. Okay, so the input was the 80, so that's what we're going to plug in as our independent variable in this case. Now, here on when we talk about now the inverse, this now is not chirps per minute, that's going to be the temperature, and what this is equal to is going to be the chirps per minute. So we are going to say now when the temperature is 65 degrees, whoops, did I do that right? Yep, the cricket, that cricket is chirping at 80 chirps per minute. Okay, so I'm going to try to squeeze in this panel here a couple more questions. I'm going to change the color on my pen if I can. So suppose that we know that f of 5 is equal to negative 17, and we also know that f inverse of 13 is equal to negative 9. So this is giving us information about some ordered pairs for f and f inverse. So the question then is, what other values of f and f inverse do we know? So trying to get you to understand here the relationship between an f and f inverse. So from this one, we know that if we input a 5 into f, we output a negative 17. So that means if we switch that, then f inverse of negative 17 must equal 5. And similarly here, if this is our input for f inverse and negative 9 is the output, then that means if we switch those, then f of negative 9 must equal 13. Okay, hopefully we can do homework 13 with this.